Welcome back everyone to another video on simplifying algebraic fractions. For today's video, we'll be focusing on multiplying and dividing algebraic fractions, so stay tuned for that. Multiplying algebraic fractions is pretty much the same as if you were multiplying two regular fractions. You multiply the denominators and you multiply the numerators together. So let's work some problems. For xy being multiplied by x squared over axy. So we say that the only thing we do is just multiply the numerators and multiply the denominators, and we simplify if we can. So let's write this as one fraction. So a cubed times x cubed over xy times axy. So let's group this, and we can use the laws of indices to help us in writing these terms to the correct power. So multiplication is just putting them together, writing them as one thing. So it would be a cubed x squared as the numerator, and for the denominator, but it is preferred if we write the terms in alphabetical order. That's what I will do. So for the denominator, we'll have a times x squared times y squared. So next thing we're going to do now that we have one fraction is to see if we can simplify anything. And for this first example, we're going to write the fraction in expanded form. So for the numerator, it would be a times a times a, that is a cubed, multiplying a 3 times. And it will be x times x multiplying x 2 times. So that is the expanded form for the numerator. For the denominator, it would be a times x times y times y. So all we're going to do is just cancel. So we can cancel one of the a's from the denominator with one of the a from the numerator. So we are left with a squared. We can cancel 2 of the x's, and we'll write back the y squared because there is, nothing is canceling that. So final answer would be a squared over y squared. Let's move to our next example. So we have 3 over pq times 4p over p plus 1. So let's first try to write both fractions as one. So we're going to multiply numerators and multiply denominators. So 3 times 4p will give us 12p. And we're going to multiply the pq by the p plus 1. And then we're going to look if we can simplify anything. So we see that p is common there, yes? So we are going to cancel our p's. So we are left with 12 over q times p plus 1. Our third problem for today is another multiplication problem. So at this moment, just pause the video, attempt this question, and then you can resume after. We are going to multiply the numerators and multiply the denominators. So it'll be m times 12 to give us 12m. And it will be 16 times 5m to give us 80m. So now that we have one fraction, we are going to look if we can simplify anything. So we see that both terms, numerator and denominator, has the variable m, so we can cancel that. And we are going to see if there's any number that can go into both 12 and 80 without leaving a remainder. If we divide both 12 and 80 by 4, we'll get 3 over 20. Therefore, our final answer is 3 over 20. So for our fourth example, we can see that it is a division problem. So division of algebraic fractions follow the same rules of dividing normal fractions. So we change the division sign to a multiplication sign, and we reciprocate the fraction that is after the division sign. So we're going to go ahead and use that concept in simplifying this problem that we have here. First thing we need to do is to change the division sign to a multiplication sign, then reciprocate the second fraction. We're going to combine by multiplying numerator and the denominators together. So we'll have 27xy over 42x. And then we're going to look if anything can be simplified. So we see that numerator and denominator has the variable x in common, so we can cancel those out. And we see that we can divide both 27 and 42 by 3. So 3 into 27 gives us 9, and we write back our y. 3 into 42 leaves 14, so therefore the answer is 9y over 14. So at this moment, just pause the video, attempt this question, and then you can resume after. So the first thing we're going to do is we're going to rewrite this problem, and we're going to change the division sign to multiplication. So 6x plus 3 over 8 times, we're going to reciprocate that second fraction. So it will be 12 over 2x plus 1. Now we're going to combine both fractions by multiplying numerators and numerator, denominator and denominator. So let's go. So it would be 6x plus 3 times 12, and we have 8 times 2x plus 1. All right, so for this problem now, there are two approaches that we can take to the first being we can distribute, expand the bracket, and then we can try to simplify. So let's go ahead and do that. So when we multiply the 12 by what is in the bracket, we'll have 72x plus 36 as the numerator, and for the denominator we'll have 16x plus 8, and that is by multiplying the 8 by the 2x plus 1. And when we are looking at the factors, we cannot simplify anything here because what we have a expression, yes? So we would, only way that we can simplify is by factoring out a term and then simplifying that. So let's factor out that 36. So when we factor out the 36, we're left with 2x plus 1 in the bracket. And for the denominator, the common factor would be 8. When we factor out that 8, we'll be left with 2x plus 1. So we realize that the brackets are the same, so we can go ahead and cancel them. So 2x plus 1 into 2x plus 1 gives us 1. So we're only left with 36 over 8. And 36 over 8 can be simplified to 4.5 or 4.5. So that's the first approach. The second approach is that we do not distribute. We see if there's a common factor there in the bracket of the numerator, and then try to factor out that common factor. So we have 6x plus 3. The common factor is 3. So we can factor that out. When we factor out that 3, we realize we're left with 2x plus 1. Okay, so we can cancel the 2x plus 1, and when we cancel that, we are left with 12 times 3 as the numerator and 8. And when we simplify that, 12 times 3 gives us 36 over 8, which gives us the 4.5 or 4.5. So there are many approaches to working out some of these problems. You just have to look on them, think it through, and go ahead. The last problem that we'll be looking on for today's video is this very complex one. We see that it has multiplication and division, and we're going to work it in parts. So I'm going to work the multiplication first. So we know that we combine the numerators and the denominators. So 5 times 6 gives us 30. We're going to write in alphabetical order. So let's look on the A's. We're just going to write by the A to the 4th power. We're going to write by the C square. We're going to write back our x cube and we're going to write back our y squared. So we'll combine them into one numerator. Now let's go to our denominator. 3 times 5 is 15. We write back our a squared, we write back our c cubed, our x squared, and our y. So now we're going to do the next fraction, which is being divided. So we change the division sign to a multiplication sign, and we reciprocate the fraction. And again, we're just combine numerators. So 30 times 4 will give us 120. We're just going to write back all of our terms. So a to the 4th power c squared, x cubed, and for the y now, we need to use the laws of indices. So we have y squared being multiplied by y to the 1st power. Bases are the same, therefore we're going to add the powers. So we'll get y cubed. Let's go to our denominator. So 15 times 9 will give us 135. And we're going to write back our... So realize that both denominators have a. So we're going to go ahead and use the laws of indices. So we get a cubed, then we're going to write back our c cubed, we're going to write back our x squared, we're going to write back our y, and we're going to write our z squared. So there we go, we have one fraction. So now we're going to see if we can simplify. Okay, so let's start with the coefficients or the numbers. The number portion of the fraction. So what number can go into 120 and 135 without leaving a remainder? So the answer is 15. 15 into 120, we're left with 8. And 15 into 135, we're left with 9. We're going to cancel our a to the 4th power and a to the cube. When we cancel those, we're left with only one a in the numerator. We're going to cancel our c squared and our c cube. So when we cancel those, we're left with a c in the denominator. We're going to cancel our x cube and our x squared. When we cancel those, we're left with an 1x in the numerator. We're going to cancel our y cube and our y. We're left with y squared in the numerator, and we write back our z squared because it will not cancel with anything. So our final answer is 8axy squared over 9cz squared. Again, thank you for watching. Stay tuned for more math content. Remember to like this video, share, subscribe, leave a comment. See you guys.